This question comes from Elena, who asks, if you somehow had a perfect survival suit, completely indestructible, perfectly temperature controlled, with unlimited oxygen, and you stood on the surface of every planet in the solar system, what would each one actually feel like? Great question, Elena. The answer involves crushing pressure, rivers of liquid metal, and the uncomfortable realization that our solar system is almost entirely trying to kill us. Let's take the tour. Mercury is the closest planet to the Sun, and it immediately breaks your expectations. You might expect it to be the hottest planet. It is not. But it is trying its best. The side facing the Sun reaches 430 degrees Celsius, hot enough to melt lead. The moment you step into the shadow of a crater, the temperature plunges to minus 180 degrees Celsius. Mercury has no atmosphere to hold heat, so the transition between scorching and freezing happens within meters. Standing on Mercury feels like standing on the moon. Dead, gray, cratered, silent. Gravity is only 38% of Earth's. You weigh roughly a third of your normal weight. The sky above is completely black even during the day because there is no atmosphere to scatter light. The Sun hangs in that black sky looking 3 times larger than it appears from Earth, blazing with terrifying intensity. Mercury rotates so slowly that a single day lasts 59 Earth days. You would stand in daylight for weeks before the slow rotation finally brought darkness. Even with your perfect suit, the psychological weight of that unchanging black sky and that enormous motionless sun would be extraordinary. Venus is where the solar system gets genuinely hostile. The atmospheric pressure on Venus's surface is 92 times that of Earth, equivalent to being 900 meters underwater. Without your perfect suit, you would be crushed instantly. The temperature is 465 degrees Celsius, consistent across the entire planet, day and night, poles and equator, because the thick atmosphere distributes heat perfectly. The sky above Venus is a sickly orange-yellow. Clouds of sulfuric acid hang overhead at high altitude. The light that reaches the surface is dim and diffuse, like an overcast day on Earth but with an orange tint that never changes. What would strike you most is the wind. Near the surface, winds are actually slow, only a few kilometers per hour, but the air is so dense that even a gentle breeze pushes against your suit with significant force, like standing in a slow-moving river. The clouds above rotate around the entire planet in just 4 Earth days, driven by ferocious upper atmosphere winds exceeding 350 kilometers per hour. Venus is the clearest example in our solar system of a runaway greenhouse effect. It had liquid water billions of years ago. It lost everything. Mars is the most survivable planet beyond Earth, and it is still trying to kill you without your suit. The atmosphere is 95% carbon dioxide and about 1% as dense as Earth's. Breathing it unprotected would be fatal within minutes. The average temperature is minus 60 degrees Celsius, though it swings between plus 20 at the equator on a summer afternoon and minus 125 at the poles in winter. Standing on Mars, you would see an orange-red sky caused by iron oxide dust suspended in the thin atmosphere. At sunset, the sky turns blue near the horizon, the exact opposite of Earth. The Sun appears about 60% the size it does from Earth. Gravity is 38% of Earth's, same as Mercury but with atmosphere, making movement feel bouncy and efficient. Walking feels effortless. A casual jump would take you nearly 3 times as high as on Earth. The greatest danger on Mars is the dust. Planet-wide dust storms can last for months, blocking sunlight entirely. The dust is fine, toxic, and gets into everything. The Perseverance rover has documented winds of over 120 kilometers per hour during storm season. Mars is close. Mars is interesting. Mars is still very far from comfortable. Jupiter has no surface. This is the fact that reframes the entire experience. You cannot stand on Jupiter. There is no ground to stand on. You would fall through the atmosphere indefinitely, sinking through layers of increasing pressure and temperature until you were crushed and vaporized simultaneously. But let us say your perfect suit handles this too. As you descend, the sky changes from pale blue to darker hues. The famous bands and swirls of Jupiter are cloud systems thousands of kilometers wide, driven by winds exceeding 600 kilometers per hour. The Great Red Spot, a storm larger than Earth, has been raging continuously for at least 350 years. As you sink deeper, hydrogen gas becomes liquid without any clear boundary. It just gradually becomes denser. Deeper still, at pressures millions of times greater than Earth's surface, hydrogen becomes metallic, conducting electricity like a metal, while remaining technically a fluid. This metallic hydrogen ocean is what generates Jupiter's enormous magnetic field. You would never reach the center. Long before then, every instrument in your suit would fail. Saturn. Saturn is Jupiter's quieter, more beautiful sibling, and equally unsurvivable. The same story applies. No surface, descending layers of gas becoming liquid, becoming metallic hydrogen. But Saturn is less dense than Jupiter. Famously, Saturn is the only planet in the solar system less dense than water. If you could find an ocean large enough, Saturn would float. What makes Saturn extraordinary is the rings. Standing hypothetically in the ring plane and looking outward, the rings stretch across the sky in a flat, glittering band. Billions of ice and rock fragments, ranging from grains of sand to objects the size of houses. The rings are 282,000 kilometers wide, but average only about 10 meters thick. Impossibly thin for their scale. Saturn's winds reach 1,800 kilometers per hour near the equator, the fastest in the solar system. Uranus and Neptune. These two ice giants belong together because they share the same brutal hospitality. Uranus is the coldest planet in the solar system, despite not being the furthest from the sun, minus 224 degrees Celsius at its cloud tops. It rotates on its side, tilted 98 degrees, meaning each pole spends 42 years in continuous sunlight, followed by 42 years of total darkness. Neptune has the strongest sustained winds in the solar system, over 2,100 kilometers per hour. Its Great Dark Spot, a storm system the size of Earth, appears and disappears over decades. Both planets have interiors of water, ammonia, and methane compressed into a hot, dense fluid under enormous pressure. Not quite ice, not quite liquid, not quite gas. Something in between that has no common name in everyday life. Neither offers a surface. Both offer pressure, cold, and wind beyond anything Mercury, Venus, or Mars can produce. The final answer. So what would surviving on every planet actually feel like? Mercury. Extreme heat and cold simultaneously. Black sky, sun 3 times larger. Absolute silence. Venus, crushing pressure, 465 degrees Celsius. Orange toxic sky, sulfuric acid clouds, slow dense wind. Mars, orange sky, blue sunsets, bouncy low gravity, planet-wide dust storms, minus 60 degrees Celsius average Jupiter. No surface, 600 kilometers per hour winds, Great Red Spot larger than Earth, sinking into liquid metal forever. Saturn, same as Jupiter but less dense than water, rings stretching across the entire sky. Uranus, minus 224 degrees Celsius, sideways rotation, 42-year polar nights. Neptune, 2,100 kilometers per hour. Winds, disappearing storms the size of Earth, furthest and darkest. Every single planet in the solar system, without exception, would kill an unprotected human within seconds to minutes. Some faster than others, some more dramatically than others. Earth is not ordinary. Earth is the anomaly. Every other world in this solar system exists as a reminder of exactly how precisely everything here had to go right for any of us to be standing on a surface, breathing freely, looking up at a sky that is exactly the right shade of blue.